right. And let me just double check, make sure that the recorder is actually recording. Yep, it is. All right. So we'll go ahead and get started right away because we want to review the final exam practice questions. And it's already online. You can actually download and take a look at those files if you want to. But I did not use a zip file because when I did this, I was on the Linux system. I did not think of doing it in a zip way. I just did it the usual way that I do things in the Linux system. So if you don't know the Linux command to do it, I'll go ahead and upload a zip file later on, but not right now. Okay, so we'll go to the downloads folder, and I'm going to get to the questions. So each question, kind of like your second exam, each question is a CPP or C++ file, and the question text is embedded into the file itself. So we'll go ahead and just take a quick look at, let's focus on one question at a time. So we'll look at Q1 first, question number 1. So here is question number 1. And is the text too small for people back there, or can you still read it? Still okay? Okay. So there's a subroutine called process, and there's a main program, and then the question text is right here. So we'll go ahead and read the question text first, and then we'll go back and see how we can figure out the answers to each one of these questions. Answer the following questions. If the input is ABC \n, the \n means the carriage return. So you type ABC on the keyboard, and then you press the return key. What is the output of this program? And the program has several output lines. The first line is going to be process returns blah blah blah, okay, which is a value. And then the second line is just a prompt. It says process line is as follows. Okay, there's not supposed to be a space in between. And then the line right on line 43, which is right here, this is where you have to supply the actual answer. Then there are several. With this particular question, there are 4 test cases. So you have to tell me what is the output for each test case. And the last question is a little bit trickier. The last question is, what is one potential input so that the following is the output? In other words, we know the output of the program is process returns 0. Process line is as follows, which is AHDR. And the question is, what do you have to specify as the input in order for the output to be AHDR? Okay, so that's kind of the reverse of the first 3. The first 1, 2, 3, the first 3 questions. The last one is a little bit more difficult because it is asking you to reverse the effect of the program. Okay, so that's one type of question that I will ask in the exam. So now it's time to go back to kind of take a look at the program itself. So we always want to start with the main program because that's the entry point of the entire program. So it always helps to take a look at main first. So we started with main. We have char line 81, which means line is an array of 81 characters. If you have any questions at any time, just raise your hand and I'll try my best to answer your question. The second line is something that we should be somewhat familiar with. It is just reading a line and reading a line from standard input file and putting it into line as a buffer, as an array of characters. So this time we are reading into line up to 81, and line has 81 characters, and we are looking for \n, which is the line feed character, as the end of the line. Okay. Yep. Go ahead.
What is size of line? Is that just
the size of line is just the number of bytes allocated to whatever line is. And this time, because line is an array of 81 characters, so size of line is just 81. And then on line 28, we have a kind of long line because it's split into 2 lines. I'll explain the first line first. So on line 28, we are using cout to print an output. And the output says, the first part is in double quotes, which means whatever I put here is going to be a part of the output, which is really just process returns and the space after that. And then after that, we have the actual call to a subroutine called process, and we are passing two parameters to it. The first one is line, which is our buffer or array of characters. The second one is size of line, which is the number of bytes that we have allocated to line as an array of characters. The next line is easy, it's just the end of line. Okay, so it will terminate the line and start the next line. And the next line is just displaying a prompt here to explain what is following, which is process line is as follows. Okay, and it has its own end of line here. And the last line that we are printing is really just line as a buffer. So I'm reading a line in, store it into an array of characters, do some processing with it, and then print it back out to standard output. That's the general idea of main. So you can see that main itself does not really quite tell you how to derive the output from the input. That is all done in process. So process has two things that it is doing. One is it is processing line, and then the second one is it is also returning a value. Is that okay? Because it is printing the return value on line 28, but then on line 31, we are printing line, which is affected by the call to process. Are there any questions about the main program itself and the two things that you need to get out of process? One is the return value. The second one is what it does to the parameter line. Any questions? No questions? Okay. So if there are no questions about this, our main focus is going to be on the subroutine process. Okay. So subroutine process is taking two parameters. One is an array of characters, or pointed to a char, if you want to call it that. And the second one is n, which is just an integer. So we want to now take a look at the rest of this subroutine. It has two local variables. One is I, one is result. Result is initialized to 1, and there's only one place that will also change it, and that place is on line 18, where it can turn into a 0. So you kind of have to keep in mind that result can be changed, and that is also what we use as the return value right before we get to the end of the entire subroutine. Line 9 is kind of important because it is the beginning of a for loop. So the beginning part of a for loop, the first part is the initialization. Fairly easy stuff, we're just initializing I to 0. The second part is the condition to stay in the loop. Now that is a little bit longer, okay? And it is basically saying if buffer bracket I, which means the element at index I is not a null character, and the character after that is also not a null character, and I plus 1 is less than n, okay, then we want to do the following. The body of the for loop is this part here. It has one single conditional statement, and the conditional statement has a condition of buffer bracket I is greater than buffer bracket I plus 1. Okay, so I'm comparing two elements that are adjacent to each other and see if the first one is greater than the second one. So in this case, we're actually comparing ASCII code, but I won't ask you anything that will involve looking up the ASCII code table. So the input is just going to be A, B, C, D, E, where E is greater than D, D is greater than C, C is greater than B, B is greater than A. It's all going to be either uppercase or lowercase. So you don't have to remember, our lowercase, earlier or smaller than uppercase. So that's it makes it easier for you guys to kind of process this without using an ASCII table. So inside the yep, go ahead.
So the ASCII code of lowercase and uppercase is different?
Lowercase would start with 6-1 in hexadecimal, and uppercase starts with 4-1 in hexadecimal. So when you compare lowercase a to uppercase a, lowercase a is greater than uppercase a. But I won't be asking you to remember that, because most people cannot remember it. All right, so inside the conditional statement, we have a sequence of assignment operations that should be a little bit recognizable by now, okay? So I'm just going to test to see if anyone in this class can recognize this particular pattern. What does it do? Swap, exactly. And what exactly is it swapping? What are the two things that it's swapping?
Buffer I.
Nope.
The previous
Yep. So basically, buffer bracket I and buffer I bracket I plus 1, the two elements of the array, are exchanged. Okay. So if the first one is greater than the second one, then the position will be exchanged. Is that okay? And it also has a side effect. The conditional statement also has a side effect of turning result into 0. Now you can see that result is initialized to 1 all the way here, but when you get into the loop, the only thing you can do is to turn it into a 0. Once it turns into a 0, nothing can turn it back into a 1. So that means you only have to get into the then branch of the conditional statement once, and that will turn into a 0 and never turn it back into a 1 ever again. Okay? All right. So that's basically what process is doing. Okay? It's basically scanning through the entire array up to a null terminator. And whenever it sees a character is larger than the next character, it will exchange the positions of those two. That's what it's doing. Are we kind of doing okay with this? So this is what you have to do during the test, is to analyze the code and then figure out what it's doing. So you might need to kind of write your own comment, next to the code. So as you process, as you read and parse and analyze the C code, you will also kind of jot down some notes and go, okay, this is doing this here, this is doing this here, so that you have an understanding of the actual code and what it is doing. All right, so now that we know what the subroutine is doing, let's take a look at the test cases and figure out what would be the answer. Okay, the first one is the input is A, B, C, and then a \n. Okay, so what the program is really doing is it's first comparing A and B, because these two are the adjacent characters. And the question now is the ASCII code of A greater than the ASCII code of B? Nope. Okay, so would anything happen? Do we get into the then branch of the conditional statement? We don't, right? Because the conditional statement says, if the first letter is greater than the second letter, or if the ASCII code of the first character is greater than the ASCII code of the second character, then we do something about it. But in this case, A has a lower ASCII code than B, so we're not going to do anything. In the next iteration, it'll be processing B versus C. Same thing, okay? The ASCII code of B is not greater than the ASCII code of C, so we won't trigger the then branch of the conditional statement. So basically, nothing happens. Now, what about the line feed character? The line feed character is not a part of the string, because we use the line feed character to indicate the end of the line, so it won't read the line feed character into buffer. It is just an indicator and say that, oh, we're done reading a line, return that string without the line feed character in the string itself. So that means that what we see as the line feed character here, in buffer or in line, this will be the null terminator.
Or 0?
0 is also basically a null terminator or null character has an ASCII code of 0. That's basically the 0 that we were looking for.
So then the condition will be true that C is bigger than 0.
Nope, because the loop will terminate first. The loop will terminate if the first character is a null or the second character is a null. So in this case, we'll encounter this case first when I is 2. So when I is 2, buffer bracket 2 is going to be the letter C, which is not null, but the character at buffer bracket 3 is going to be a null character. This condition becomes false, and because this is a conjunction, the entire thing becomes false and you get out of the loop. All right? Yep.
What is N?
Sorry?
N?
N. Oh, N is just a counter. It's just a boundary. It's like a string N compare or string N copy. It limits. In the event of I cannot find a null terminator, N will basically still stop the whole process and make sure that we don't overrun the buffer. Yeah. All right. So let's get back to the question itself. Okay. So now that we kind of know what the program is doing, so in this case, what about the return value of process? In other words, the local variable result in process was initialized to 1 before the loop. So did we get a chance to get into the then branch to turn it into a 0? The answer is no. So that means process will return the value of 1, and the process line is going to be just ABC itself, and that's the answer.
So,
well, you can specify \n if you want to, but that's not required.
okay.
Yeah. All right. So next line. Okay. Next one is a little bit more tricky, and for this one you might need to track it on a piece of paper. So with this one, the first letter is C, the second letter is B. So in the first iteration of the for loop, we'll be comparing C to B. And the ASCII code of C is greater than the ASCII code of B, which triggers the then branch. Okay, we'll get into the then branch. The then branch will exchange B and C. Okay, so B becomes the first letter, first character, C becomes the second character. It will also change result from 1 to 0. Okay, and that means we can answer the first part of the question right away, because once result turns into a 0, it does not have a chance to turn back into a 1. So we can pretty much conclude right away that it is returning a 0. Okay, now this is the tricky part, because when you process this one, you might want to do something like this, because this is the result after the first iteration. So in the second iteration, it's going to look at C and A. Okay, this is the tricky part, because we are making changes to the array, so you need some way to keep track of the current content of the array, because the next iteration is going to use the result of the first iteration. So now we're comparing the second character and the third character. The second character is no longer a B because we exchanged in the first iteration of the loop. So now we're comparing C and A, and obviously C is greater than A. And as a result, we go into the then branch again and exchange C and A in the second iteration, which means after this, we end up with B, A, C as the result. In the third iteration, or at the beginning of the third iteration, it will check the condition, and the condition is comparing C with a null terminator. But because it's a null terminator, the condition will basically become false for the condition of the for loop, and we exit the loop. So BAC is the output of this particular case.
So when we do the second iteration of the process subroutine, it won't return a second 0.
It will only return a single value. The entire process subroutine will scan through the entire array, and you can get into the then branch multiple times, but if you get into the then branch multiple times, let me go back to the code here, it will just reset result to 0. But if it's already 0, it's okay. I mean, it's just overwriting 0 with a 0. It doesn't really return a value. It does not do any returning until we get to line 21. So that's the result of the second test case. The third test case, and if you apply the same method here, in the first iteration, we're comparing letter A with letter S. It's not greater than, so nothing happens. So after the first iteration, we will get the same thing back. After the in the second iteration, it will compare lowercase s with lowercase d, and the case is greater than, so that means those two will be exchanged. So we end up with ADSF. In the third iteration, we'll end up with ADFS because lowercase s has an ASCII code that is greater than the ASCII code of F. So that's why we end up with ADFS, and that will be the result of process line. So the string becomes ADFS, and the process returns a 0, because anytime you get into the then branch just once, it will reset result to 0. So are we doing okay so far with this particular question? Okay. So the last question, or the last sub-question, is actually the hardest one. And it is basically saying we know the output already. The output is process returns 0, which means we get into the then branch at least once. The process line is as follows. Okay, we have A, H, D, R as the end result. And the question is, what do you think is, or what is one possibility as the input in order for this to be the output? HADR. Okay.
Process.
What? Yeah, this is the processed line, which means this is after we perform all the logic in process. Okay. So you can give it a try. Okay. There are only so many combinations, right? So you can give HADR a try first. Okay. So let's see what happens. If the input is HADR, the first iteration will recognize H is after A and do the exchange. So it becomes AHDR, right? But then the second iteration will compare H and D and recognize that H is greater than D, and it will do another exchange, which is ADHR. And then in the third iteration, it will compare the H and the R, and H is not greater than R, and it won't do any exchange. So the output, if the input is in fact HADR, the output is going to be ADHR, which is not AHDR. Okay, but you can see the problem here, right? The problem is D is here, and D is actually less than H, and that's why we have the second exchange, which kind of screw up something in the output. Not, it makes the output not what we want. Okay, we know we're on the right track. Okay, we know HA is the beginning. HARD, exactly. If you have HARD, hard, exactly. Yep. Then it makes sense, right? Well, not the hard part, but the output part. Okay, in the first iteration, it compares H to A. H is greater than H, so it will exchange those two. In the second iteration, it compares H with R this time. H is not greater than R, no exchange is taking place. So after the second iteration, you have the same thing back. Now in the third iteration, it compares R and D. R is greater than D, so it would exchange those two and end up with AHDR, which is the output here. Okay, so it's a little bit. It takes a little bit of time to kind of solve it. It's, but that's the nature of this particular question. Is you have to kind of understand what the subroutine is doing. The first three cases are fairly easy because you're just following the logic. The last one is a little bit harder because you have the end result of the scrambling and you have to reverse it back to the beginning, which has a little bit to do with the movie, the imitation game, because that's what Alan Turing had to deal with. They end up with the scrambled text. They have to find a way to reverse it back to the original. Of course, the difficulty of this one is nothing compared to what he had to deal with. All right, so that's question number one. Yep, go ahead. Absolutely. Have some more? This is good? Okay. And at the end of the class, if someone reminds me, I can zip up this whole thing and post it on Moodle. And it's being recorded as well right now. And let me just double check. The recorder is on. Yep, go ahead. Unzip it. You can download it. You have to have a 7-zip to unzip it because it's a tar.gz file, which is not native to Windows. Windows like zip files, but tar.gz is kind of like a Unix thing. Yep.
And the final is open notes and everything too?
Yes, the final exam is paper only, but it's open book and open notes. You can find anything that is either printed or handwritten prior to the test and bring it with you. Question? Yep.
How many questions?
How many questions? I have not decided on that yet. It depends on the difficulty of each question, or what I perceive as the difficulty of each question. My tendency is to give you more questions, and each one is less difficult. And I would call this one kind of difficult because it is kind of involved. Yep.
And how much time?
How much time? 2 hours. 120 minutes.
7,000.
It's going to be a solid 2 hours too. There's no fluff in those 2 hours.
40%.
All right, so let's take a look at the second question. Second question, always read the question first, okay? The question says if the input is A, B, C, D, E, F, and then the \n, which means the end carriage return pressing the enter key, what is the output of this program? So this one is only going in one direction, not really quite the bi-directional thing. Okay, so let's take a look at the main program first. The main program is not really that amazing, okay, because now we have two arrays, okay, we have buffer A and buffer B. Each one is an array of 81 characters. We have the typical thing, we are reading one line, okay, just one, into buffer A. And we have basically the same construct as in the previous program, okay? We specify the buffer, we specify how many bytes are in the buffer, and what is the end of line character. So nothing really surprising here. And then we call a subroutine called do something, okay? Well, do something is going to do something with buffer A and buffer B. So both of the local variables of main, are being used, but we have to look into the subroutine itself to find out which one is being changed and why and how it's being changed. And line 23, pretty easy. Whatever buffer B is, we're going to print it out with an end of line after that. And then the main subroutine is going to return. We're done with the main subroutine. So once again, the magic is not in main itself, but in do something here. Now this time, do something looks pretty short and pretty simple, okay? So, and it's only using index 0 and index 1. So how difficult can this possibly be? Well, the difficulty is on line 12. So when we get to that line, I'll explain what it does. Okay, so for the time being, let's just start with line 5, which is the beginning of the subroutine. So line 5 doesn't really do much. It is just saying, is the first character of P2, which is the second parameter, a null character? That's all it's asking. And the answer is no, because the input is A, B, C, D, E, F, right? So we are inputting, so the array buffer A will end up with the ASCII codes of A, B, C, D, E, F, and a null terminator after that. So obviously the first letter is not a null. So what do we do? Go to the else branch, right? So the else branch doesn't seem to do much. The first statement is line 11. And line 11 is just going to say, okay, let's copy that non-null character from P2 to P1 into the same position. So I'm not doing any type of swap, reverse, or anything like that. But then we have line 12, which is the most difficult line to understand, is what are we doing here? Okay, I am taking the address of P2 bracket 1 and pass it to parameter P2, and I'm taking the address of P1 bracket 1 and pass it to P1 as a parameter. And the worst part is, this is recursion. I'm calling do something from do something itself. So that really is the whole thing. This is the pivot of the entire thing, is what are we doing on line 12? And that is the one line that I have to explain in more detail. Okay. So the first thing we want to do is to say, okay, have we seen anything like this before? Well, we have seen pieces of this type of thing before, but not in this particular combination. So what you need to do is to find out, okay, based on what I understand each one, what is going to happen here? That is what you need to do, is to plug in the components that we have already discussed and explained, and you have used those individually, and now you're going to say, okay, but how do they plug in? Okay, this program does compile. Okay, it is not going to be a syntax error. This program does compile. All right, so let's start with the things that we usually start with first. Okay, taking the address of is the last thing that you do. In the actual test, if anyone wants clarification, I can always specify the order of the application of operators. So in this case, taking the address of, which is the single ampersand, is the last thing that we do. So the first thing we do is to do the indexing operation. In other words, if I give you P2 as a pointer to an array of characters, do I know how to get to the second element of the entire array? Exactly, it's the second one, right? The second one is the second one. Okay, so if I can get to the second element of an array, can I take the address of that element?
Yes.
You can take the address, right? So if I can take the address of that element, can I pass it as a pointer to a subroutine that is expecting the address of a character. Because it isn't the address of a character, right? All right, fine. Okay, hold on a second here. Take a step back. What exactly, in this particular case, if the input is A, B, C, D, E, F, which means buffer A ends up with A, B, C, D, E, F, and a null character in it. So in that particular case, what exactly is is the second character of the entire thing? It's B, right? So I'm passing the address of B to P2 of the same subroutine. Okay, so let's remember that first. What about the other side? Let me highlight the other side first. Okay. What is that? Well, that's the second character of buffer B, right? Because we use buffer B to specify P1 when we call do something. So that's the one right next to the one that just got the letter A. Is that okay? So we are passing the address of the byte or the character right after the character that got the letter A as a parameter to do something again. Is that part okay?
So we're not actually passing the.
We're not passing
B.
We're passing the
address
address
of B.
of that position. Yes.
B.
Okay, so that is the most important part. So that question is a very good question because you have to remember we're not passing characters. We're passing address of a character in this case. All right? Are we still doing okay so far? So in the second invocation of do something, P2 is going to be the address of B in the entire array. Now, but if you can get to the letter B of that array, can you still get to C, D, E, F, and the null character? As using array indexing. The answer is yes, you can, right? Okay, okay. I think what we need is to visualize this. Okay, so we'll go to, I'll just use a mouse pad to visualize this first. Okay, so you guys can tell me whether this is working or not. Okay, so we know that buffer A looks like this. Okay, so with buffer A, we know that buffer A bracket 0 gets the letter A, right? This is basically after the get line statement. So we have buffer A bracket 2, bracket 1 gets B, and so on. So I'm just going to do this a few times. I don't need to finish the whole thing. So we know this is A, B, C, D, E, and then the indexes will be 0, 1, 2, 3, 4, and so on. And then we have something on the other side. We have buffer B, bracket 0 is unknown to begin with because it's not initialized. Okay, so we have buffer B, bracket 1, 2, 3, 4, and they were initially uninitialized. Is that okay? Now, when we talked about the concept of an array, I remember distinctly that I said that it's contiguous. In other words, the elements are right next to each other in memory. Do you guys still remember that part? Because that really is an important concept in this particular question. Yes?
Okay, so then you go into do something on line 11, buffer B of 0 gets an A.
That is correct. Okay, so in order to show you what the subroutine is doing, let me see how I can do that. How many people kind of have an idea of what this subroutine is actually doing? Okay, kind of. Well, give me your best guess. Go ahead.
Well, I'm still trying to figure out on 12, how can you pass P2 of 1 when there's an unknown number in there?
If you want us to understand, there's which is right next to your character. You're just passing.
Yes, but then you're using it up there, and it does not equal to 0. So then.
But you're passing the address. You're not passing the character. You're passing the address of a particular element in the array.
Okay, so then you go back into
Okay, so let me try to do it this way and see if this makes sense to people or not. Okay, so what we'll do is we'll trace the whole program, kind of using the same construct that we had before. Okay, so in this case, we start execution on line 21. Line 21 really doesn't have much to talk about because it ends up with A, B, C, D, E, F, and a null character in buffer A. So if you really want to go through the whole thing, it's going to be very tedious to finish the entire program. So I'm not going to finish the whole thing. So number 5 is going to be F. Number 6 is going to be the null terminator. Okay, this is all done by getLine itself. So getLine will end up with A, B, C, D, E, F, and a null terminator in buffer A. So that's what line 21 is going to do. Line 22 is the call. Okay, so now we have to keep track of the calling. So line 22 calls do something. And every time you call a subroutine, you have to identify what are the parameters, right? So in this case, we know the parameter of P1. What is the parameter P1 in this case? The first time we call do something on line 22, what are we actually passing to parameter P1?
Nothing.
It's the entire buffer B. But but since P1 is the address of one single character, which one are we passing?
A.
The address of A, right? So can I do it like this? P1 as an address to a character is really the address of buffer A bracket 0. Is that okay? Oh, P2, yeah, you're right. P1 is using buffer B, so sorry about that. Okay, this is buffer B, and then P2 is going to be the address of buffer A bracket 0. Is that okay? Okay, but this is actually very important. So after we get into the subroutine, the first one you get to is line 5. Line 5 is saying, well, if you look at P1 as an array, what is the first element of that array? That will be the first question mark here. And what about P2? Well, this is actually asking what is P2 bracket 0, so it should be asking P2. So if you look at P2 as an array, what is the first character of that array?
A.
It would be this one, right?
Yeah.
So we are now saying, okay, is the ASCII code of A 0?
No.
Nope. Okay, fine. We'll go to the else statement. So when we go to the else statement, we have line 11 here. So line 11 has the effect of saying basically buffer B bracket 0 gets buffer A bracket 0 because P1 points to buffer B and P2 points to buffer A. So the first element of P1, if you look at it as an array, is the first letter of buffer B, and the same thing is similar with P2. Okay, so that ends up with this as a result, right? Because buffer B, the first element of buffer B, is not affected. That's not the tricky one. The tricky one is line 12. Once you understand what line 12 is doing, then you can do this one more time. You'll finish get to the next invocation, and then you'll get a pretty good idea of what this is actually doing. You don't have to trace the entire thing. Okay, so here's line 2. Line 12. Line 12 is the one that is going to be important because it is going to call do something. And every time we call a subroutine, we have to identify what are the parameters that we are passing to the subroutine. Okay, so now what are we passing to P1?
The address of P2.
Go ahead.
The address of buffer B bracket 1.
The address of buffer B bracket 1. Okay, so let's see if everybody can get this one. It's not buffer B bracket 1, it is the address of that. Okay, so let me just stop here a little bit and make sure that everybody can get that part. On line 12, we use P1 bracket 1, or the address of that, to pass to P1. And in the caller, P1 is the address of this byte here. Is that okay? That's the first invocation. By the time we get to line 12, we are saying, oh, give me the address of the next thing, and we'll pass that to the next invocation. Who's right next to buffer B bracket 0? Buffer B bracket 1. Does it have an address? Sure. And we can pass it to the next invocation of do something. And that's why in the next invocation, the second invocation of do something, P1 as a parameter is now the address of buffer B bracket 1. Is that part okay? Okay. What about P2? Well, let's take a look at the call itself. In the first invocation, P2 is the address of buffer A bracket 0, which is this guy here. Takes up one space, one character in memory. When we get to line 12, we're saying, oh, don't pass the address of that thing, pass the address of the next thing, because that's basically saying the next thing, right? Okay, so who's right next to it? This guy.
Buffer A1.
But we are not passing buffer A bracket 1, we are passing the address of buffer A bracket 1. So in the second invocation of this subroutine, P2 is going to be buffer A bracket 1. Are we still doing okay so far? Because this is really the trickiest part of the whole exercise. Yep.
So starting from line 22, we're just working with addresses of the arrays? Yeah.
Elements. Yeah, we're working with addresses of elements of the array.
Okay.
Yep.
Wouldn't it be useful right now to actually state what's in like say P1 is an unknown and P2?
Nope, because P1 is the address of a byte, P2 is the address of a byte. So if you look at P1, it doesn't tell you what is the content at that address, it just tells you which address we are interested in. But it doesn't tell you the content or the value at that address right away.
I just have a feeling once we're going to start undoing the invocations, that's going to be useful.
Then we'll get to, when we get to the line where we need to refer to the content, then we'll refer to the content at that time. Is that okay? Okay. All right, so once we set up all the parameters, we'll start execution from the beginning of the entire subroutine, which is starting on line 5. Line 5, this is the other part where you have to understand, because once you understand this part, the rest, is just, oh, okay, so we know what the subroutine is going to do now. Okay, let's look at line 5 and what it's doing. Line 5 is saying, even though we know P2 is just a pointer to a character, can we look at an address of a character as the beginning of an array? Okay, yes we can, right? This is actually one of the unique features of C and C++ where a pointer can always be seen as an array. Okay? And if I see P2 as an array, what is the first element of that array?
0, bracket 0.
Knowing that P2 is the address of buffer A bracket 1, which is this one here, so we are looking at the address of this guy here. What is the first element if this is the beginning of an entire array? It will be the letter B. Okay, let me say that again, okay, because I can see some frowning. So let's go through this one more time. So we are now executing line 5, where we have to retrieve the first element by looking at P2 as the beginning of an array of characters. Is that statement okay? So the second thing we have to do now is to find out, okay, so what is P2? What is it pointing to? It's an address of something. What is it? Whose address is it? And by passing the parameters from the previous invocation, we know that P2 is the address of buffer A bracket 1. So P2 in the second invocation of do something is the address of this byte here. On line 5, we are looking at this location and say, we are treating this location as the beginning of an entire array of characters. Yep.
So the 1 becomes the 0 then?
No.
Because
It's not, no. Buffer A bracket 1 becomes P2 bracket 0. I have an analogy that people can understand, but for now, I'll defer the analogy until a little bit later, okay? All right, so if we're looking at this as the beginning of an entire array, what is the first element of this array? The letter B, right? Because the first element has the same address of the entire array, right? Is the ASCII code of B 0? No. So we go to the else branch again on line 11. And after this line 11, I think most people would say, oh, okay, I get it. I know exactly what this whole thing is going to do. So let's take a look at line 11. Line 11 is basically the same thing as line 5, except we have an assignment operation instead of just comparing. So it's going to go to P2 and say, I'm going to treat P2 as an array. And the beginning of the array is the address of buffer A bracket 1. Buffer A bracket 1 is right here. I'm looking at this address and say, this is the beginning of an array. So if this is the beginning of an entire array, what is the content of the first element? It's the same question that we asked before. B, lowercase b, is the content of that address, right? So the lowercase b becomes the right-hand side of the assignment operation. Let's look at the left-hand side of the assignment operation, P1 bracket 0. P1 is the address of buffer B bracket 1, which is this address here, which is this byte here. If I look at this as the beginning of an entire array, what is the first element?
B.
No. The first element is whatever is at that location.
No.
Buffer B bracket 1 is the first element of P1.
Yeah, buffer A.
Sorry?
Buffer A bracket 1 is now.
So the assignment will do this. Is that what you mean when you said B?
Yes.
Okay. All right. So if that is the end result of line 11, when we get to line 12, what are we going to do? It's going to do something again, right? And this time when it calls do something, it's going to pass parameters as well, just like last time. And what exactly are we passing this time? Let's take a look. So what is P1 this time?
The address of buffer B bracket 2.
Exactly. Buffer B bracket 2. What about P2?
What address of buffer A bracket 2?
Exactly. So the most important concept that you have to understand in this case is I can take the address of anything, okay, and say, oh, look at this as an address. You know what? But I can also look at it as the beginning of an entire array. Then I can refer to the second thing and the third thing and so on. Yep.
This is a much tedious way of trying to populate an array.
Copy
Yeah.
is a string copy, but in a recursive way.
That's what I thought.
Yeah, you know, the figuring out part is not so bad, but to understand the line 12.
Do you understand line 12?
Yeah.
Well, line 12 is the key part. I mean, that really connects all the concepts. Is the address of anything can be treated as the beginning of an array. That's the first concept. The second concept is in an array, everything is contiguous. The second item is right next to the first item. The third item is right next to the second item, and so on. Yep.
Can you go back to the code and look at the question again?
Yep. The question is, if the input is A, B, C, D, E, F, and then press the enter key, what is the output of this program? The output is just printing out what is buffer B.
Yeah.
Yep. It's just A, B, C, D, E, F. Same thing. So to answer this question, the output is A, B, C, D, E, F. And if you want to specify the end of line, that's fine. If you don't, that's fine with me too. Okay. Now, the last case is actually important because the recursion is going to end at some point. It ends when we see the null terminator of P2. But when we see the null terminator, we just don't say, okay, let's quit, let's go back, okay? We have one last thing to do, is to copy the null terminator too, so that the destination string, which is buffer B in this case, would also have a null terminator. Now, I know this explanation here is kind of difficult to, this is the best I can do to visualize the whole thing. The other thing you can also do is to do this in GDB. Not during the test, okay? But since you have the source code now, I recommend that you compile the code, run it in GDB, stop it on line 12, okay? Stop it on line 12, take a look at what is P1 and what is P2, single step, so it goes all the way back to line 5 in the second iteration, and then print out what is P1 and P2 again. It will become more obvious of how this whole thing works. And also, you can also you can specify A, B, C, D, E, F as the input, and put a breakpoint every single time it gets to line 5. Okay, the last time you get to line 5, do a backtrace, because when you do a backtrace at that point, it will print out all the parameters of all the previous invocations. Then you will actually see the pattern of this whole thing. So that becomes also useful. Okay, instead of just saying that, I'm going to do it. It's actually easier doing it than actually saying it. So that whole saying of those who can do, those who cannot teach, is actually not true. It's actually easier doing than teaching. Trust me on that one. Okay, G++ Q2 -G -O Q2 Q2.cpp GDB Q2. And I said put a breakpoint on the first line. This is a trick you guys can do too. If you want to put a breakpoint at the entry point of a subroutine, you can just say B and then the name of the subroutine. So in this case, B do something will actually do it. You can actually set a breakpoint like that, which is kind of handy because you don't have to look up the line number. And then we can just go ahead and run the program and specify A, B, C, D, E, F, press the enter key. This is the first invocation. Continue, second invocation. Continue the third invocation, fourth invocation. The one thing that you have to watch out for is whether we still have any characters left in P2. Okay, so when P2 becomes a null string, then it's time to stop and take a look back at the parameters. So continue, E, F left, F left. We can do it one more time. Now it's an empty string. So when you look at P2, it is printed as an empty string because it consists of one single null character. Now some people can kind of see that pattern right now, because whenever you do it, whenever we stop at the entry point of a subroutine, it tells you what is a pointer. In addition to what it's pointing to, it tells you what address is in the pointer. In this case, P2 has an address that ends with B4. Before it was ending with B3, before it was ending with B2, and then before it was ending with B1. So we can definitely see a pattern here. Now, if this is not obvious enough, the other thing we can also do is to do a backtrace. BT is backtrace, and backtrace does something like this. It shows you that our current invocation is #0, and right now P2 has an address of blah 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 B4, and the invocation that got us here to begin with had P2 being blah 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 B3, and the one before that had P2 being blah 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 B2, and so on. So this becomes a little bit more obvious, because you can actually see the address of the parameter and actually see how it is just increasing by 1 with each step. So are there any questions about how to use GDB to help you kind of understand the whole construct? Yep.
Can you do the backtrace real quick?
I just did. This is the result. This is the command BT. I press the enter key here, and this is the output of backtrace. Well, I have done backtrace maybe once or twice before in this class, but it is a very useful command. So from here on, you can single step and actually see how it goes back to the previous invocations, but I'm not going to do that because going back doesn't really do anything interesting in this case. Questions? No questions? All right. If there are no questions, we get to question number 3, and we have another 15 minutes or so to go over. Question 3, I think, all the way up to question 6. Okay, this is question number 3. Question number 3 is just main ball by itself, no recursion this time. So what it's doing is, okay, it has 3 local variables. Password is an array of 9 characters. We have I as an integer, ch as a char. From line 9 to line 12, okay, I'm hoping that some of you can kind of recognize what it is doing. It's basically just going from 0 to up to the second last character of password and assign everything to lowercase a. That's basically what it's doing. It is saving the last byte of password to be initialized by line 13, which is a null terminator. So if you look at line 9 all the way up to line 13, it is initializing password, PASSWD, to basically 8 lowercase a's and then plus a null terminator. That's basically what these lines are doing. Line 14 is saying, okay, let's start with 3 in I, okay? And line 15 is something that should be somewhat familiar. The first part of line 15 is just reading from standard in a character, and we want to read it into ch. Now, when we look at this context, it is on the left-hand side of a conjunction, which means we are now looking at the value, the return value of the right shift operator as a Boolean. The right shift operator returns cin itself. Whenever you look at cin itself, which is an I stream, input stream, as a Boolean, it is also reporting whether it is reading something correctly or not. Okay, so that means if we did read something into ch, then we want to check whether ch is the tilde symbol or not. If it is not the tilde symbol, we want to perform this operation and then go back and do it again. And the input in this case is ABC, the tilde symbol, and the carriage at the end of line character. So the first letter is A. A is definitely not the tilde symbol. So what we do is on line 17, we are now changing password bracket 3, because I has a value of 3 in this case, to lowercase a, which is not doing anything because it started off with lowercase a to begin with. So the magic or the tricky part of this particular program is on line 18. Line 18 is doing some math with I and also the size of password. So let's try to figure out what it's going to do here. All right. What is the value of I at this point? 3 plus 13. So let's go ahead and express the entire thing first, and then we'll do the calculation. There's a mod operation here. In the exam, I'm not going to explain the symbols. Okay, so you're supposed to remember or have your notes available so that you can look up and find out what the symbols are representing. Okay, so this is the mod operator. What is the size of password? What is the number of bytes that we are using in password? 9 bytes. Okay, and 9 minus 1 is 8. So this is the whole expression. So basically it becomes what? 16 mod 8? Mm-hmm. And 16 mod 8 is what? 0. Okay. So I becomes 0 after the first iteration of the loop. So in the next iteration of the loop, we are going to read the next character into ch, which is the letter B. The letter B is not tilde, so we come back here. So in the second iteration, password bracket 0 is going to get B. So the string becomes B and then followed by 7 A's and then a null terminator. Is that okay? So by the time we get to line 18, then we have 0 plus 13. The second part, or the divisor, never changes because the size of the array does not change. 1 is a constant, it doesn't change. So it's always 9 minus 1. So in this case, we are saying what is 13 mod 8? 13 mod 8 is 5, because 5 is the remainder of dividing 13 by 8. Okay, so when we get back to line 15, we're going to read C in. C is not tilde, so we get to line 17 again. So this time we're changing password bracket 5 to C. So at this point, if we want to be clear, it is B followed by 4 A's, and then a C at this point, and then another 2 A's and a null terminator after that. That's in password PASSWD at this point. And then we go back to the beginning. So after the C, we're going to read the tilde symbol. So after we read the tilde symbol, this expression is going to fail. It's going to return false because tilde does not equal to tilde is false. So we get out of the loop. We print out what is password, which is what we have just described here. It's B, A, C, A, and that's the answer for the first test case here. Okay? So the second test case is a little bit more involved, but it's basically just figuring out the mod operation. Yep.
So we allocated 9 spaces in array
Right.
to include the null character.
That is including the null character.
And
That's what line 13 is doing, is to put the null character into the last byte of password.
and that's why we have 8 A's
That's
after
why
the
we have.
A's.
Yes, that is correct. That's why we have 8 A's. But you can also tell that we have 8 A's by the loop of on line 9, because we started off with 0, and we
Mhm.
stay in the loop as long as I is less than the size of password, which is 9. 9 minus 1 is 8.
8.
So from 0 to 7, there are
That's
8
8
iterations.
iterations, okay.
Exactly. That's why we're putting 8 A's into array password. So what this program really is doing is scrambling, some words that you type as as the input, and it just kind of scrambles the ordering of the letters and print it back out. So it's just a quick and easy way for you guys to generate your password for whatever account you want to use. Yep, go ahead. Question? No? Oh, okay. So that's question number 3. And let's take a look at question number 4. Question number 4 is interesting because there's a whole big gap here, which means you're going to write some code over there. Okay? So this time I'm describing what you have to do, and then you're going to have to do it. So the question is asking, write some code in is sorted as a subroutine. That's the name of the subroutine. So that it returns 0 if and only if some characters in buffer, which is the parameter as an array, is up to the first null character are not sorted in a non-decreasing order. Non-decreasing means you can have the same letter repeating itself, like AA, BB is okay, but BA is not going to be okay because BA is not non-decreasing, it is actually decreasing. Are we doing okay so far with the terminology? Okay, and this statement implies the second one, but just in case it's not clear, I also use a second statement. The second statement says it will return a non-zero if and only if the characters in buffer up to the first null character are sorted in a non-decreasing way. So if it is sorted, return a non-zero. If it is not sorted, returns a 0. That's basically what it's saying. Your code will be graded on, based on the amount of compile time errors. So that would, no, I really should not be calling it this way. It should be more clear. Points will be deducted based on the amount of compile time errors and the logic or the correctness of the logic. So you do have to make sure that the logic is right. You're not writing pseudocode anymore. So you got to make sure that you're using proper C++ code. Efficiency and elegance are not grading criteria. So don't spend your time during the final exam and say, I think I can make this go a little bit faster, or I think I can save another pair of curly braces. Don't do that, okay? If you think it works, just stop and move on, okay? You may assume that buffer is properly terminated by a null character to begin with, okay? So your job is just to write the code, okay? All right. So this is one of the very few questions where you have to write some code instead of just reading my code. Some people claim that reading my code is actually much harder than writing their own code. I'm not sure about that. All right, so what do we need to make sure that all the characters are either in order or at least find one that is out of order and we're
if
done?
statement. If
We need an if statement, but the if statement only does it once.
You need a loop.
Well, you can either do a loop or you can make it recursive, okay? And I don't think anyone in this class wants to do the recursive version of this, which actually in some way is easier to understand. Trust me on that one too. It is easier to understand. But let's say we don't want to do it in a recursive way. We don't have enough time, but I really want to. I will give you the recursive version of this as well. Okay. So if you make it an iterative version, which means you're using a loop, okay? So we need some kind of a loop. So I'm going to use some pseudocode notation and I'll fix it up until, and then it will become good. Okay, we'll return some kind of result here. So this is definitely not right C++ C code, but when I'm starting out, I'm going to write it like this. What do you think would be a good reason to stay in the loop, not getting out of the loop? Okay.
Decreasing order.
Okay. So how about not having scanned the entire array? Would that be one of the reasons why I might want to stay in the loop? Okay. Well, the array is not fully scanned. All right. That's one part of the reason to stay in the loop. What about the other part of the reason to stay in the loop? If I have found one pair of elements to be out of order, is the entire thing out of order?
Yes.
Well,
Yep.
You can do. You can use a little bit of the previous code from the previous, like question 1.
Yes, you
Yeah,
can.
yeah. And then.
You can actually use that. That's a good idea. I'm so glad that you mentioned that, because you are actually remembering in the first question, it already contained most of the logic of what you need to do here. Not all. I mean, just in fact, you have to take out some of the logic from the first program in order to make this work. Okay, but I'm going to pretend that we did not have the first question and just try to work it out step by step. Okay, so stay in the loop. We want to have two conditions being true at the same time. We have not scanned the entire array yet, and nothing is out of order of the portion that we have scanned up to this point. So when both of those conditions are true, I think we have a good reason to stay in the loop. Is that okay? Or not, at least not get out and have a conclusion. So if we are in fact staying in the loop, what should we do in the loop here? Right? So we want to scan the next position, the next elements, right? Okay. All right, fine. That's what we're going to do. Okay. So now that we have this, how do we turn it into actual C code? Okay, first of all, if you're going to do anything about elements in an array, you will need to find some way to index those elements, right? So let's go ahead and declare a local variable I, and we'll just kind of comment here and say this is an index into buffer. Okay, so this is an index. And do we want to scan the buffer from first to last, or do we want to scan it from last to first? We have to do it from first to last, because if we do it backwards, we don't know where the null terminator is, right? So we have to scan it from the beginning to the last. So I has to be 0 because I is the index and 0 is the index of the first element. All right. So let's take care of this part first. So I'm going to do a copy of this line so that we can see the original one and then the code that is expressed in C. Okay. So how do I know that we have not fully scanned the entire array yet? And this is supposed to be a null terminator string.
Is not equal to 0.
Okay. Fine. Okay. But
How
when
does buffer 0? It has to be the last.
oh, sorry, buffer I.
Yeah.
Yep. Okay. But when you are comparing, you're comparing buffer bracket I to whatever is next to it, right?
Plus 1.
So we have to make sure the other one is also a non-null character. Now we cannot miss one. Okay, and I'll tell you why. We need both of these. The reason why you need both of these is, what if the string is null to begin with? What if it's an empty string? If it's an empty string and you're only looking for a buffer bracket I plus 1, then you're missing the null terminator itself. Then you'll be doing a whole bunch of processing, but it's not really a part of the string. So that's why you need to catch both of them, and there are multiple ways to catch both of them. This is one way to do it. All right, so we got the first part covered. If the array is not fully scanned, which means we have not seen the end of string null terminator. Fine. What about nothing is out of order? How do we know nothing is out of order? Well, nothing is out of order means everything is in order, right? And if I can make the assumption that everything before buffer bracket I is already in order, then my only job is to make sure that buffer bracket I is and buffer bracket I plus 1, those two are in order. Okay, so we have to
one
say
is
buffer
greater
bracket
than
I
the other.
is less than or equal to, not greater than.
Okay.
Is that okay? Everybody got this part? Okay. And how do we get to the next element?
It doesn't have to be or equal to, right? Because
It has to be or equal to because it is non-decreasing. They can be the same.
A or B.
Yeah, it can be A, B, C. Yep. Okay, so how do we move on to the next element?
Plus plus.
Yep, I plus I plus equal to 1, I gets I plus 1, they will all do the same thing. Alright, so by the time we get out of the loop, we are getting out because of one of these three reasons, okay? At least one of these three reasons, right? So how can we make a conclusion whether the array is sorted or not?
If buffer bracket I is less than buffer bracket I plus 1.
But that won't work if I actually scan the entire array and buffer bracket I plus 1 is the null character, because everything is greater than the null character.
So you'd have another conjunction with the buffer bracket I plus 1 not equal to the null character.
Okay.
Would that logic work?
It can be simpler. It's a little bit simpler than that. Go ahead.
I think what you should do first is actually do the changing itself.
Sorry, say again?
You should do the changing itself in the loop.
Change.
Yeah, if you know if it needs to be changed, then
Nothing is changing here. I'm just scanning and seeing whether it is sorted or not. Okay, how about this? What if I just say, if buffer bracket I is not 0 and buffer bracket I plus 1 is also not 0. If it is not the case that if bracket I is not null and bracket I plus 1 is not null, I know the array is not sorted. Actually, I got it reversed. Sorry. Take the negation out and put. No, I was actually right, but I'm re-expressing it in an easier to understand way. There we go. Oops. There we go. Is that making more sense? If I get out of the loop because I saw the null terminator, doesn't that mean that I did not see anything that is not sorted? Yep. So that would do it. Okay. But don't take my words for it. Okay. Some of you will take my next class, CISP 310, and possibly CISP 440 in the future. You always say, I don't think so. Okay. Prove it. Yep. Go ahead.
So this doesn't actually ask you to sort them. This asks you if it's sorted or not. Oh, because that.
Okay.
I was thinking.
So let's go ahead and try this out. Okay, so G++-O Q4Q4.cpp. Wow, I did not make any syntax error. So A, B, C, D is sorted. Okay, fine. Let's try something that is a little bit trickier. Okay, give me something tricky.
BCAD.
And then put like a 10 in there.
B, C,
10.
A, B,
Put a 10.
10.
No, after the C, just in the middle of the BC.
Ah, B, C, 10, A, B.
Yes.
It's not sorted. How about something even trickier, like an empty string?
Okay.
It is sorted. What about a string of one character?
Sorted.
Should it be sorted or not?
Sorted.
Z. It is sorted.
Multiple. So
Huh?
10 Z's.
10 Z's, multiple but same value. Okay, that's a good one. It is sorted. So it does work as far as we can tell, right?
You get 100%.
I get 100% unless in the question I say it has to be recursive. So I'm going to give you the recursive solution to this. I know, some of you are saying, I don't need to know that. But I do want to show you that. Yep, go ahead.
With capitals, feel anything?
Sorry?
With capital letters?
Capital letters will screw this up because all capital letters, all uppercase characters, are less than their lowercase characters. So if you intermix in uppercase and lowercase, almost for sure it's going to be unsorted. Unless you just have one single word like this, no. Like uppercase A, B, C, that will still be okay because lowercase a is actually greater than lowercase uppercase a. Okay, so this is the recursive version. Okay, because many of you are thinking, we don't need to know that. Yeah, we do. Okay, so so here's the thing. Okay, so we check for the null string first. Okay, so we say, what if this is a null string? The easiest way to know this is a null string, which means a string with nothing, is that, right? If the first letter or the first character is a null character already, it's a null string. It doesn't, it has no content. And tell me again, is an empty string sorted by its very nature? It is sorted. Okay, so we'll say return 1. Fine, cool. Else, okay, I'm using the proper nesting of conditional statements. Okay, so if buffer bracket 0 is not a 0, I still have a second chance of getting something that's really simple. Because what if the second character is 0, is a null character? That's also an easy one, right? Because if I get to here on line 27, it means I am seeing a string that has one single character, so one single letter. Because the first letter is, or the first byte is non-null, but the second one is. And by its very nature, is it sorted or not? Yes. It is sorted. Cool. All right, so now we have something that is a little bit nasty. It's like, okay, we got 2 letters that are not null, and now we actually have to do some comparison between buffer bracket 0 and buffer bracket 1. So we'll say, okay, let's compare. Okay, if buffer bracket 0 is greater than buffer bracket 1, can we conclude? When you look at line 31, if the condition of line 31 is true, can we make any conclusion?
It's sorted.
It is.
Sorted.
It's not sorted. It's not sorted because we want an array that is non-decreasing. Non-decreasing, and this is definitely decreasing, right? Okay, so we don't need to look any further and say, no, it's not sorted, we're done. Right? If you're given a string with only the first part, the first 2 letters are not sorted, you don't need to look any further. Does that make any sense? All right, here's the recursive part.
You need an else if again.
No, we just need an else here. Okay, so the else is going to say, okay, by the time we get to line 37, what does it mean when we get to line 37? It means that we have 2 letters or 2 bytes, 2 characters in buffer. Neither is null, because then I can make a conclusion real quick. And it is not out of order. So if I have A and B as the first 2 characters, that will get me onto line 37. Because I cannot determine whether the entire string is sorted or not at this point. I cannot determine yet. Is that okay? So what we'll do is we'll say, up to this point it is sorted, but there's a chance that it may not be sorted, with the later portion of the string. Okay? So I'm going to ask someone else to see whether it is sorted or not. And where do you think I should start with the next invocation?
Buffer I plus 1.
That makes it recursive. Because what I'm saying is, okay, someone gave me a string, okay, an array of characters. The first 2 are sorted. I cannot tell whether the whole string is sorted or not. Okay? So what I'll do is I'm going to say, but I'm too lazy to find out myself, so I'm going to ask another person to figure this out. So how can the next person figure out whether the whole string is sorted or not? I'll give it the next location, right? So whatever place I start off with, that's done already. There's no need to check it again. I'm the one who did it. And I can just tell the next person, hey, you know what? Start with the second byte of me. And then you can compare with the third byte and so on. You do whatever you need to do. So if that person comes back and say, you know what, the rest of the string is sorted, knowing that my part is already sorted up to this point, I can now go back to whoever is asking me and say that, oh, you know what, the whole thing has to be sorted. Is that making any sense? Because I know that my part is already sorted. If the rest of the string is also come back and saying, you know, it is also sorted, then the whole thing has to be sorted from my perspective. So I can tell whoever is calling me and say that, you know what, my part, the entire part is sorted. I can tell you that already. On the other hand, if my part is sorted, like AB, but the rest of the string, for whatever reason, is not sorted, then the whole thing is not sorted, right? You only need one part of the string not to be sorted for the whole thing to be not sorted. So my answer to whoever is asking me whether this part is sorted or not, the answer is going to be a no, it is not sorted. Is that making any sense?
Can I just put on the question, my part is sorted, the rest of it is not.
Well, but the key, okay, the most important part of this particular recursive version of is sorted is line 37. Line 21, line 27, and also line 33 are quote-unquote trivial because you're just looking at the first letter, the first character. It's a null, it's an empty string, okay, it has to be sorted. You look at the first character, it is not null, but the second one is. You have an array of one character, it has to be sorted. And then you look at both characters, there neither is a null character, but it is in order. It is sorted, right? Oh, excuse me, I take it back. You look at the first two letters, it is out of order already, so the whole thing has to be unsorted, so you can return 0. So the important part is line 37, which means the part that I'm responsible for is sorted, but I don't know about the rest of the string. Ask someone to handle the rest of the string. And the question that you're asking is basically saying, treat the second character that I'm dealing with as the beginning of your beginning string, and do the same thing. So in this way, it is the same thing as the other recursive subroutine, the one that copies everything. It's basically doing exactly the same thing. Are we doing okay so far with this? Okay, we're out of time, unfortunately. We're out of time, and we still have 2 more questions to go, so I'm going to have to make a recording and post it later. If I don't do it by tonight, okay? If you see that there's nothing posted by tomorrow, send me an email so that you guys can get the solution of question 5 and 6. But that also gives you some time to work on it first, which is probably a good idea. Yep.
We have class Monday, right?
I have office hour on Friday.
What about on Monday? We have class?
Nope.
No class on Monday.
Nope. Friday is the first day of final exams. Yep. All right. So.
And then 5 is